Hello and welcome to Quadratics 4.1 Vertex form. Okay, this section is going to get confusing. It's gonna be a section that we're going to work on all year long. So don't worry if you can't get it right off the bat. We're gonna revisit this particular concept and set of topics whenever we come to a brand new equation that is gonna represent a different graph that we're learning for the quarter. Okay. So yeah, like I said, you're gonna see it very often. You're gonna see it at least once a quarter. So if you don't get it the first time, then just don't give up. Keep on learning at least a couple of things each time you see it, and eventually you'll get it. Okay. So this section is basically gonna tell you how graphs change when you put certain numbers in certain spots in the equation. Yeah, that's the best thing I can explain about what's going to be behind this entire section. Yeah, all we're going to do is we're just going to put different numbers, different signs like plus or minuses in random spots in the equation. So in this case, quadratic. Yeah, and based on where we put the number, based on what kind of number we put there, it's going to do all kinds of changes to the graph. And we're going to basically have to predict based on our understanding of where the number is and how big or how small the number is, and the sign of the number, we're going to be able to predict what kind of change we'll see in the graph. Okay, so it's going to basically give us the ability to read equations and make predictions about what the changes will be in the graph compared to one number there versus another one. Okay, so I think that's enough of a background. So yeah, just copy down the blue words that are in the blanks. I'm not going to stop to let you guys copy it down like I would if it was a normal class, because you guys can just push pause. Yeah, so you can read through this, but as I do my first problem, I'll talk about all these things that are in the blue inside the blanks. So you'll start to see the connection as I start to explain the problem. So I'm not going to go in explain these things right now, but I will during the problem when I actually go live in a real first problem. Okay. Okay, here's your second slide. You guys can copy down the words that go in these blanks. And like I said, if I happen to get off this slide too fast, just push pause. Yeah, rewind, push pause, and you can copy all the words down. All right. Okay, and then for this, I guess we've covered three forms, yeah, of our quadratic. The first one being standard form, yeah, where it's the ax squared plus bx plus c form. Factored form, where when we factor it by using the techniques that we learned in section 3.2, we can rewrite a quadratic in this form. And vertex form, which is kind of like what we're going to learn today. Yeah, and you're going to learn that different numbers in different spots are going to make changes happen to the graph. All right. So each of these forms have a strength. So x-intercepts, if you want to find them real easily, use factored form. If you want to find the y-intercept really easily, use standard form. And if you want to get the location of the vertex really easily, well, yeah, it's kind of in the name itself. Use vertex form. Okay. All right. So those are just things that can hopefully make you see connections faster. Yeah. If we didn't point them out exactly, you'll start to see it as you guys get more experience in quadratics. Okay. So this slide, this is kind of important because this is going to pretty much say exactly. It's gonna compile all the things that I'm saying as I do the problem in one spot, in one slide. So this is on your your packet. If you don't have the packet, then just do a screenshot. Yeah. But this is gonna be very important because as you do each problem, you're gonna wanna look at this this chart. Yeah, this list, I guess you can say, because it's gonna tell you what each of these letters are in charge of, and how changing a number for one of these letters or changing a sign of one of these letters, how it's going to make a difference in what the graph does. Okay, so it's just a compiled list of transformations that you're going to see happening to not just quadratic, but to pretty much most of the functions that we're going to learn, the graphs that we're going to learn this year. Okay. All right, so we're also going to start introducing the concept of minimum and maximum for quadratics. You might have gone through that earlier in a previous section. Yeah, and we're also going to start to talk about domain and range. So that's going to be one thing you're going to notice that we're going to do a lot whenever we learn a brand new equation or a brand new function, that we're going to talk about domain and range. And we're going to start to identify what the domain and range are for that particular function that we're learning at the moment in that quarter. Okay, so the left side right here, the part where it says if then, that's the mathematical way of mapping out the scenario. The part that I put in blue and red on the side is, it means this exact same thing as what's in the handout, except I just use like a word form of it rather than just using all the symbols. Because sometimes if you just see things in symbols, it can get confusing. So I put it in word form. Yeah. So the part that says positive, right, corresponds to a greater than 0. Because if something is greater than 0, that means it's positive. Yeah. And flip version. If something is less than 0, that means it's negative. Yeah. And when we notice this about the a value, yeah, we can draw this conclusion about the range for this particular function, that the graph is going to be higher than k. And if a is negative, then the graph, right? So you're probably saying the graph. It says g parentheses x. So why is he saying the graph? Well, when you think about it, yeah, g of x is going to represent a graph if you were to map out the equation that we have. Yeah, so if we were to plot out the equation for any quadratic we're given, yeah, on an x and a y axis, it's going to be a graph basically. So when I talk about g parentheses x, or what you would call g of x, sometimes I use the graph and this symbol interchangeably, because yeah, sometimes it's very relatable as far as making the connection. Yeah, but like I said, once I start going with the real problems, you'll start to see the connection. Yeah, and it'll hopefully make a little more sense. But I'm just flying right through all this beginning stuff, this foundation stuff, because yeah, we're gonna get into the real stuff when we get to the problems. Okay, so let's just jump right in. Okay, so our first problem. So we start off on the easier side. Right, so the first thing you want to do is, when you see the problem, right, this is my original problem, you want to write it in vertex form. Yeah, and if you write it in vertex form, you can identify these three letters easily, A, H, and K. So these are the three main letters that we're gonna start with right off the bat. Yeah, eventually we're gonna have a fourth letter, but that's not gonna happen to the third quarter. But for now, we're gonna stick with these three letters, A, H, and K. Right? But the only thing about this original problem is, if I leave it as is, I can't identify the A, H, and K. Yeah, so right here in red, I rewrote what we have in my original problem, except I expand it so that I can see my A value, my H value, and my K value. So what are the big differences? Well, look what I did with the negative sign that's in front of x squared. I rewrote the negative sign as -1. Okay, and look what I did to the x squared. I rewrote x squared to become x minus 0 squared. So x minus 0 squared and x squared, they're the same thing. But like I said, I'm expanding how this original problem looks. I'm expanding it, yeah, so that I can easily identify what A, H, and K are. Because that's going to be your job when you first arrive on a problem. You're going to identify what A, H, and K are, and once you do, you're set. You're home free. Okay, so the x squared turns into x minus 0 to the second power. And then the plus 3, no change there. Yeah, we just leave the plus 3 as is. All right, so when you see this expanded form that I wrote in red, you're going to know that whatever's in the front is your A value, so it's gonna be known as -1. Whatever's after the minus sign, okay, I'm gonna say this phrase a lot throughout the rest of this video. Okay, your H value is gonna be after the minus sign. Yeah, it doesn't seem like it's gonna make that big of a difference when I say it like that, but trust me, yeah, that one phrase right there messes up students all throughout the year because they forget that the H value is always located after the minus sign. Okay, and then your K value is going to always just be in the back. Yeah, so if it's a plus 3 in the back there, then your K value is a plus 3. All right, and then you're going to say, since the K value is 3, do I really have to write the plus sign? And I'm going to say yes. Yeah, yeah, a plus 3 and just a regular 3, yeah, they're assumed to be positive, but I physically write the plus sign there so it reminds us of something. Okay, and you'll find out a little later why I'm doing that. Okay, so first step was to find your A, H, and K because we rewrote the original problem into this form. All right, so the key to getting the rest of this problem is knowing the correct numbers that are in the spots for A, H, and K, because look at how many different places the A value is used. The A value is used on this first line. The A value is used on this second line. The A value is used for the range. Okay, so if you can identify the A value correctly, you have a good shot at getting 3 blanks correct. You get the A value wrong, you're going to mess up 3 blanks on this problem. So this is a pretty high stakes letter as far as identifying it correctly. Okay, the H value, let's see, how many times is the H value used? It's used once here on this third line, and it's used once here in this spot called vertex. Okay, so it's used twice. So not nearly used as many times as the A value is used, but still pretty important. All right. The K value is, wow, the K value is used a lot. It's used 4 times. Once here on this last line, once more here on the vertex, once more here next to this blank called value, and once more again for the range. Okay, so as far as importance for letters, identifying the K value is probably the most important because it's going to make or break 4 blanks in this very problem. Yeah, so that's why I always tell my kids that get the A, H, and K wrong. They misidentify it. You know why you're misidentifying it? Because you're not rewriting the equation so that the A, H, and K values stick out. Yeah, and the kids always don't want to do it because it's one more step to do. Yeah, but if you're getting the A, H, and K value wrong, you're not identifying it correctly, and you're not rewriting the equation, well, guess what the solution to that issue is? Write the equation. Yeah, especially if you're getting the A, H, and K wrong. Okay, so let's go for it. Let's just go in order. So this first line relates to the A, but all he cares about is the sign of A. So this first guy says, okay, the A value is negative, so how does that affect what I'm going to write on this first line? Well, it's going to affect it by actually forcing you to write this statement that is reflected across the x-axis. So you're only going to write 2 things on this first line. You're either going to write reflected across the x-axis, or you're going to write not reflected across the x-axis. That's the only 2 things you're ever going to write. Okay, and be really careful about the wording. I'm super picky about the word choice that you guys use. Yeah, please don't say jumped over the x-axis. Please don't say reflected over the x-axis. Yeah, please don't say mirrored across the x-axis. I want you to say reflected across the x-axis. Okay, stick with the words that I use. Yeah, because I want to create some consistency. All right, so please, 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 like I said, stick with the word choice that I'm saying. Reflected across the x-axis for a negative A value, and not reflected across the x-axis for positive A values. Okay, so an easy way that I teach my kids to determine which of the 2 options are we going to pick, the not reflected or the reflected. I tell my kids this. Think of a minus sign as getting rid of something. Think of the plus sign as adding it in. Okay, minus sign is going to get rid of something. A is positive is going to add something in. So what did I say my 2 options for this sentence was, or this line was? You're either going to say reflected across the x-axis, or you're going to say not reflected across the x-axis. So the only difference between those 2 sentences are, one guy has the word not, the other one doesn't. Yeah? So look at what this guy says. This guy says A is negative, and guess what's missing? The word not is missing. If I had A as positive, guess what I would put in? I would put the word not in this sentence. Okay, so that's not the real reason why the not is not there, but I just use that comparison for kids that have trouble to remember. Okay, do I put reflected or do I put not reflected? So that's just a way that I help my students remember. Yeah, write the word not for plus, erase the word not if it's minus. Okay, all right. So this second A value says, all I care about is the number for A. I don't care about the sign. I don't care that he's negative because I already know what a negative does. It makes it say reflected across the x-axis. This second line, all he cares about is the number. So the A value is a 1. Okay, so you have 3 options for this next line. You're either going to say, why am I forgetting it all of a sudden? Okay, you're going to say vertically stretched by a factor of a number, which is your A value, vertically shrunk by a factor of whatever the number for A is, or you're going to say no vertical stretch or shrink. Okay, so those are your 3 options that you're going to say. Vertically stretched by a factor of number, vertically shrunk by a factor of number, or no vertical stretch or shrink. Those are the only things you're going to say. All right? And please don't mess around with the words. Use the exact words I just said. All right, so my A value is a 1. So ask yourself this question. If I were to multiply by 1, because that's what this does, right? That's what this A value does. It's going to be 1 times the parentheses. So I'm basically multiplying. So if I multiply by 1, do you think numbers are going to get bigger? Do you think numbers are going to get smaller? Or do you think the number is going to stay the same if I multiply by 1? Okay, so I'll repeat the question again. If I multiply by 1, do you think the answer is going to get bigger or smaller or stay the same? Okay, and I hope you say stay the same. And if you said that, then we're going to choose the option that says no vertical stretch or shrink. Because if it's not stretching or shrinking, that means it's because the number didn't change, right? If my number got bigger, I would say vertically stretch. If my answer got smaller, I would say vertically shrink. But because I multiplied by 1, my answer didn't get bigger, my answer didn't get smaller, it stayed the exact same. So that's why I'm going to say no vertical stretch or shrink. Okay, so I'll repeat this exact same phrase when I go to the second problem and the third problem and the fourth problem. So don't worry about that, okay? All right. So let's see. Where else does the A value get used? Well, it gets used in this range value over there. So I'm not going to talk about it later, but we're just going to go on down the line. Just go straight down this list. So next we're up with H. So H is 0. So remember what I said? Always look for H after your minus sign. So here's my minus sign. What number is right after it? 0. Okay. So H is going to be causing movement. Movement to the left or right. Yeah, so if you think about the word horizontal, horizontal moves left and right. Okay, so the H value controls movement left to right. Okay, so when I say the wording for this, I'm either going to say one of two options: horizontal shift to the left, blank units; horizontal shift to the right, blank units. Okay, so those are the two options that I'm going to say: horizontal shift to the right, blank units, or horizontal shift to the left, blank units. Okay, actually there's a third option because this guy's a 0. Yeah, do you think any movement is going to happen if my value is 0? Should I move left to right if my value is 0? No, actually, because it's a 0, we're not going to move at all. So we're just going to say no horizontal shift. Sorry, so there's 3 options. I kind of forgot about the 0 option. Okay, so we have 3 options for this next line, right? Horizontal shift to the right, blank units; horizontal shift to the left, blank units; or no horizontal shift. Okay, K value as well, same 3 options, except we're just going to change the word and not say horizontal, but we're going to say vertical. So your option for this last line is either going to be vertical shift up, blank units; vertical shift down, blank units; or no vertical shift. Okay, so this K value has 2 things that are important for his value. The plus sign is going to cause something to happen, and the number is going to cause something to happen. Okay, the plus sign in particular, though, is going to tell you which option you're going to choose. Are you going to choose up or are you going to choose down? Yeah, so what do you think? Do you think a positive sign relates more to up, or do you think a positive sign relates more to down? Hopefully you say the positive relates more to up, because if you said that, then you're correct. Okay, so watch how the wording for this guy is going to be. Vertical shift up. Yeah, and the reason why it's up is because the plus sign is corresponding or relating or connecting to the word up. And in your 3, it just tells you how many units up we're going to go. So vertical shift up 3 units. Okay, if this K said 0, we would say no vertical shift. If this K was -3, we would say vertical shift down 3 units. Okay. So the K and the H, they're very similar in I guess the reasoning for what we write. Yeah, H is going to be left and right, K is going to be up and down. Yeah, and H, if you want to make a connection, H is like the first letter of the word horizontal. Yeah, so when you start writing these words, don't start changing these words again, right? You guys know me already by this point as far as my word choice. I'm kind of strict with word choice. Yeah, don't just say like move up 3 units. Yeah, or slide up 3 units. Yeah, don't make up your own words that mean the same thing as vertical shift up 3 units. I want these words. Okay, I want consistency. All right, so please give me that. Yeah, because otherwise there's going to be so many different things that I have to accept, because you're going to say, well, you accepted this the last time, so why can't you accept it now? Yeah, and I've had that argument way too many times to want to do it anymore. So I just start saying, no, you stick with the wording that I have, and if you don't have the wording I have, then I have to mark you wrong. Okay, so please stick with my wording, because like I said, otherwise it's going to get way too confusing. We're trying to remember which words I accepted and which words I didn't. Yeah, as the year goes on, because like I said, this is a problem that's going to be all throughout the entire year. And to be consistent, yeah, so that I don't have to remember which words I accepted in the past and which words I didn't, I'm just going to accept these. That's it. Okay? All right, so let's move on to the right side of the list. So the vertex is going to be a set of coordinates, like an x and a y set of coordinates, so number comma number. Yeah, and the numbers that I'm going to use for the vertex coordinates are just going to be my h and k value. So if my h value is 0, my k value is 3, well, that's what's going to be my coordinates, 0, 3. Sounds pretty easy, right? You don't got to write any words. You just got to write the coordinates of the vertex based on your h and k value. Okay. This guy right here, this guy's kind of important, because we're either going to write one of two words. It's either going to be maximum or minimum. You can abbreviate it max or min. That doesn't matter to me. But you're going to write one of two words, maximum or minimum. Okay. So to know which word we're going to write, we're going to look at this picture on the right-hand side. Okay. So this picture basically tells you which way the graph is headed towards. So this graph is pointing down. Yeah, I know there's no arrows that are coming out of these two lines that are pointing down, but imagine there were arrows pointing down. Okay, and because this graph is pointing down, we have what is called a maximum vertex, or a maximum value. Yeah, so how we get that is the a is negative, so that means the graph gets reflected. So a parabola or a quadratic function, his natural direction that he wants to point in is up. That's where he naturally wants to point, up. But when this a value says it's negative, we're going to grab that parabola, that quadratic that is normally facing up, we're going to reflect him across the x-axis, meaning he's going to start pointing down. And if he points down, that means that my vertex is on the very top. He's the highest point in the entire graph. And since he's the highest point in the entire graph, we're going to associate that with the word maximum, because he's kind of like at the top of the hill. Yeah, so he's the highest point out of everybody else. So we're going to call him max. And then this last number over here is going to tell me, okay, we know that our vertex is at the very, very top, the highest point. So how high was that highest point? And that's where your k value gets thrown into the mix. So how high was my maximum value? How high was that highest point on my entire quadratic, my entire parabola? Well, the highest point was at a height of positive 3. Okay, so now we've seen this k value used 3 times. Once to get the vertical shift up 3 units, once to get the y coordinate on the vertex, and once more to figure out the maximum value. Okay, so then you're going to look at this next one, domain, and you're going to say, wow, there's no letters next to domain. There's no a, there's no h, there's no k. So how do I know what this guy is? Well, think about what domain is. Domain connects to the letter x. Yeah, and range connects to the letter y. So domain is going to be going left and right. Range is going to be going up and down. Okay, so for domain, as far as he's concerned, we want to know which x and x values do I need, yeah, to draw this graph. Yeah, when this graph gets drawn and he starts going on forever, which x values are needed as this graph goes left and right, yeah, on the left side and on the right side. And the thing about a quadratic or a parabola that you got to understand is this graph is going to forever go down in a downward direction. And while it's going in a downward direction, it's not going to go straight down. It's going to go down and it's going to get wide at the same time. And it's going to keep on getting wider forever. So my domain for a parabola or for a quadratic function is always going to be this phrase, x colon all real numbers. Okay, so when you think about domain, he connects to the x values, and because this parabola, this quadratic function, keeps on getting wider as it goes down forever for this particular problem, because this graph is going down, we're going to have all real numbers. yeah, for my domain. Okay. Range is going to be which y values were used as this graph was drawn. So this guy's not going to be all real numbers, because if you look at this picture, does this graph go up and down forever? No, this graph only goes down forever. Yeah, but he reaches a height, yeah, the highest point in the graph, and he's not going to go any higher than that highest point. So we already know what that highest point is. It's 3. Yeah, so we know this graph is not going to be drawn at a height of 4. This graph is not going to be drawn at a height of 5. This graph is not going to be drawn at a height of 6. This graph at the most is going to reach a height of 3. So when I talk about the range, yeah, we know that my range cannot go higher than 3, because 3 is the maximum value. Yeah, so when I talk about what y values are needed to get this graph drawn, yeah, here's how the phrase is going to look. Yeah, so g of x, which I know, which I sometimes substitute the word, the graph. Yeah, so think of it this way. So the graph is lower than, or you could say less than or equal to. Yeah, so my graph is lower in height compared to the height of 3, or is going to be equal to the height of 3. Yeah, so the height of my graph is lower than 3, and it also can be equal to 3. Okay, so that's what you can use to understand the range. Yeah, and this is a less than symbol because my a value was negative. And because my a value is negative, we use less than. If my a value is positive, we would put greater than. And then my 3 is because that's my maximum value. This whole graph has to be below 3. Yeah, so my graph is at a height that is lower than or equal to 3. Yeah, so that's how we would translate the statement that we have right here. Okay? All right, so make sure when you write domain and range, you have it written exactly how I have it there. Don't just ignore the x colon and write all real numbers. Don't forget to write g of x twice. Okay, so don't forget to do all that kind of stuff. I'm kind of picky with that, so be careful. Okay, so next problem. Okay, so let's see. Remember the first step? Rewrite your equation so that you can easily identify a, h, and k. So in my original problem, do you see a +1 written in the very front? Nope, but mine does. Yeah, because when I write it, I know that that's my a value. Okay, then I have x minus 5, that stays the same, squared, and then minus 8. So hardly any changes there. The only change was I added in the +1 in the very front, so I can identify that as my a value. Okay, so here's where the tricky part is. Yeah, so like I said in the previous problem, your h value is always located after your minus sign. So here's my minus sign, and what's right after it? 5 is right after that. So look what I put for the h value. I'm not putting -5. You know how many kids put -5 throughout the years? And I know why. I know exactly why they put -5 throughout the years, because your eyes are saying it's a -5, because you see a negative and you see a 5, so naturally you're going to put -5 for the h value. But like I said, you got to remember the phrase. The h value is always located after the minus sign. So if that's my minus sign, what's right after the minus sign? 5. So you put a +5 for your h. And your k value is just whatever at the back end, so put -8. Okay, so this time my a is positive. So what did I tell you? Negative says erase the word not. Positive says write the word not. Yeah, negative means erase, positive means write it in. Yeah, and you're going to just use the exact same phrase for both sentences. Yeah, reflected across the x-axis. So you're either going to erase the word not or you're going to add it in. So this plus sign says add in the word not. So that's what I did. Actually, I put no reflection. So same thing. So not reflected across the x-axis, no reflection across the x-axis. That's the same thing. That's fine. Okay, you can put either or. Not reflected across the x-axis or no reflection across the x-axis. I'm fine with both. Okay, because I'm going to use those interchangeably as well. All right. The a value is 1. So you guys remember what I did the previous problem, right? If I were to multiply by 1, does my answer get bigger? Does my answer get smaller? Or does my answer stay the same size when I multiply by 1? And multiplying by 1 means my answer stays the same size. So that's why I'm going to say no vertical stretch or shrink. All right. H value +5. So you got to remember, it's either going to be horizontal shift right, blank units, or horizontal shift left, blank units. I know last time we had no horizontal shift, but that's because it was a 0. We don't have a 0 this time. Yeah, we have a +5. So our options are horizontal shift right blank units or horizontal shift left blank units. So the only difference is one option says the word right, the other option says the word left. So what do you think this plus sign is going to tell you to do? This plus sign says choose the word right, or does the plus sign say choose the word left? Yeah, what do you associate positive sign with, right or left? And hopefully you say I associate the plus sign with right. And if you said that, your horizontal shift will be horizontal shift right 5 units. Okay? So let's look at the K value. You got 3 options, but you're only going to be choosing from 2 because this is not a 0. If your K value is a 0, yeah, that's easy. No vertical shift, but it's not a 0. So you got -8 for your K value. So your options are vertical shift up 8 units or vertical shift down 8 units. You're going to choose one of those 2 options. Yeah, so what do you think the negative sign is going to tell you to do? Choose the up or the down version of the sentence. And hopefully you say the negative is going to make me choose. You can mouth it, you can say it to yourself. The negative sign is going to make you choose down 8 units. Okay? So like I said, right? These 3 letters, you identify them wrong, a whole lot of pieces to this puzzle is going to fall. Yeah? So if you're having trouble identifying the right A, H, and K, you got to rewrite your equation just like I have here. Okay, that will make or break your experience. Yeah, because you get these first 3 letters wrong, a whole bunch of other stuff becomes wrong as well. So you got to be super careful. Okay, so vertex is going to be a coordinate, H comma K. Yeah, and my H value is +5, my K value is -8, so 5 comma -8. That's pretty simple. Okay. Next one, remember the options. You're either going to choose maximum or minimum. Okay, so this time your A value is positive, which means you didn't reflect. So remember what I said? The parabola in its natural state is going to be facing up. It's going to be like the letter U. So if it's like the letter U, it's pointing up. Yeah, and since we didn't reflect, the U stays a U. It doesn't turn into an upside down U. Okay, so if it's just a plain old U, let's look at the dot, which is right here, this red dot right here. Yeah, that's called my vertex. Is this red dot that's called my vertex at the top of the parabola or at the very, very bottom of the parabola? So if you look at this picture, right, it doesn't look like the last one. It doesn't look like a hill. This looks like a valley. So this vertex is at the bottom of the valley. So we can think of this vertex being located at the lowest point of the entire graph, or what we can relate to as minimum. So like I said, we got 2 options. We're going to choose maximum or minimum for this blank right here. And because my vertex was at the lowest point of the parabola, we're going to associate that with the word minimum. Okay, and the K value is going to be -8. So the lowest point of this entire graph is located at a height of -8. Okay, domain, just like the previous problem, and just like the next problem, and the next problem after that, is always going to be x colon all real numbers. So don't forget the x colon. A lot of kids forget that. All right. So range, right? You're going to write g of x colon g of x. You're going to write your k value +8. So the only difference, right? So here's what you got to remember. Yeah, the only 2 things you're going to ever write for range for a parabola is g of x colon g of x is greater than or equal to -8, or g of x colon g of x is less than or equal to -8. So the only thing that changes is one option has greater than or equal to, the other option has less than or equal to. But everything else stays the same. Both options have g of x colon g of x. Both options have the exact same k value, -8 for one option or -8 for the other. Okay, so how do I know this is going to be greater than or equal to? Well, because your A is positive, right? And an A is positive means you're going to have, it's going to connect to greater than or equal to, and it's going to be basically the entire graph, right? So notice how I translate g of x. So the graph is higher than -8, right? So if you look at the graph, this graph is in blue. So look up here on this picture. The graph is blue. Yeah, so my graph is higher, right? Symbolized by this greater than symbol. My graph is higher than -8. So you see how this range, yeah, connects to this picture over here. So when I see g of x, I say the word the graph. When I see greater than, I say the word higher than. So the graph is higher than -8. So my blue line is higher than this red dot, which is at a height of -8. Okay, so that's how you can think of the range. All right, so I'll explain the range the exact same way for the next two problems. So hopefully you get it off of these 4 tries that I explain this kind of a problem. Okay, so let's look at number 3. Okay, all right, so notice how when I rewrite the equation, they're gradually getting more and more complex. Okay, so notice what changes I have. This guy has just regular plane O2. What did I rewrite the plane O2 as? +2. And here's where kids get all crazy. The original problem has x plus 8. Look what I have, x minus -8. And you're wondering, why do I do that? Why do I make x plus 8 as x minus -8? Didn't I just make it look way more complicated? But you got to remember, what is the phrase I taught you for h? When you find h, you always find him after the minus sign. Do I see a minus sign in this original problem? No, I see x plus 8. I don't see any minuses at all. So what I did was I rewrote the positive as 2 negative signs. And the reason why I did that is, like I said, when I rewrite the positive as 2 negative signs, the phrase works. That my h value is located after the minus sign. So here's my minus sign, and what's right after this minus sign? -8. So my h value is -8. Okay, so this could very well be super complicated for a lot of kids. It's gonna cause you some issues the entire year. Yeah, you just gotta practice, people. Yeah. You just got to practice. You just got to keep on reminding yourselves about that phrase. And when you do, it'll eventually make sense. I promise you, it'll eventually make sense. But you got to keep on referring back to it. You can't just say, I'm going to do it one time each quarter and I'm good. It doesn't work like that. You can't just remember it just by doing it one time each quarter. You got to refresh and practice and get in your reps. Okay. The k value, it was -3 in my original equation. It's still -3 in my final equation. Okay. So the biggest difference is the plus sign turned into 2 minuses. And like I said, the reason is so that I can identify the proper h value as being -8. Okay. So other than that, everything else is the same. A is positive, so I include the word not or no. Yeah, so no reflection across the x-axis, or you can say not reflected across the x-axis. Same thing. That's the same thing in my eyes. Okay, because we're still using the same word, reflection, reflected. That's basically just different conjugation of the same verb. Yeah, we're still saying across, we're still saying x-axis. Yeah, we might not be saying not, yeah, but not, no, that's the same thing in my eyes. Okay, and oh wow, we finally have a number that is not 1 for my a value. My a value is a 2. So in the previous 2 problems, when I had a was 1, we didn't have vertical stretch or shrink. We don't have a 1 this time. So let's see what kind of a change that makes on this sentence. Okay, so you got to remember. Yeah, how did I teach this second line? I just said to you, when I multiply by this number, does my answer get bigger? Does my answer get smaller? Or does my answer stay the same size? So ask yourself that question. When I multiply by 2, yeah, when I multiply by 2, does my answer get bigger, smaller, or same size? So hopefully you say my answer gets to be bigger. And if my answer gets bigger, watch what I write. Vertically stretch. Yeah, because getting bigger, you can compare it or connect it to the word stretch. If it gets smaller, you can compare it to the word vertically shrinks or shrunk. Yeah, so multiply by 2, answer gets bigger, vertically stretch. Then you got to remember, by a factor of 2. Okay, so keep track of the words, people. Yeah, because I'm very picky on word choice. Yeah, you forget words, you make up your own words. Yeah, I'm going to mark it wrong because, yeah, otherwise it's hard to be consistent. Okay? Okay, h value, -8. So like I said, the options are horizontal shift left, 8 units, horizontal shift right, 8 units. So what do you think the negative is going to pick? Does the negative pick left or right? And hopefully you say the negative sign will pick left, like that. Okay? And same for the k. Vertical shift up, 3 units, vertical shift down, 3 units. Those are your only choices that we have when I see a number. If I see a 0, yeah, no vertical shift. But this is not a 0. So does the negative sign pick up or down? So hopefully you say the negative sign picks down. So vertical shift down 3 units. Okay. Vertex, this isn't changed. It's just your h and your k. So -8, -3. That's pretty simple. This graph is not reflected. Yeah, so if it's not reflected, it stays a U-shaped parabola, U-shaped graph. So if it's a U-shaped graph, this is going to be a minimum because my vertex is at the very, very bottom. So that's going to be a minimum. So when my vertex is at the bottom, it's minimum. When my vertex is at the top of the parabola, it's a maximum. Yeah, so drawing this shape out based on your understanding of reflection versus not reflection, yeah, is huge. So if you want to just sketch this out as soon as you figure out if it's a U or an upside down U, that's going to help you out huge as far as figuring out max or min. Okay, and then the value is just going to be your K value, so -3. Your domain, that's the same thing as we did the previous two columns, all real numbers, don't forget the X. Okay, your range, like I said, you got two options. This inequality symbol is either going to say greater than or equal to, or it's going to say less than or equal to. Yeah, so because this is positive, it's greater than or equal to. So the graph is higher than -3. So my graph, which is in blue, yeah, is higher than the height of this dot, which is at -3. Yeah, so that's how you can use the translation of what we're writing for range to connect to the graph. So the graph, yeah, g of x, the graph, which in this picture is the blue thing right here, this blue curved line. So this is my graph, the blue thing. Yeah, you can translate greater than or equal to as higher than. So the graph is higher than. So this blue line is higher than my dot, which is at -3. Yeah, so the -3 right there. Okay, so that's how you can connect the picture to this range statement. Yeah, and it's going to be difficult at first. I know, class. It's going to be difficult. Yeah, but like anything else, just practice. Don't give up. Just keep on trying. Rewatch this video as many times as you need so that you get it. Okay? All right. And last problem. So let's see, what kind of changes do I have from original problem to rewritten problem? So -½ here, -½ there, same thing. X plus 5, ooh, I think I have to make a change. X minus -5, right? So I can see that the H value is located after the minus sign. Then -16 for my original, -16 for my rewritten. Same thing, that doesn't change. Okay, so I can identify my A, H, and K. Yeah, so my A value is negative. So we're going to erase the word no or not. And we're just going to say reflected across the x-axis because I erased the word no. Yeah, A is half. Yeah, so remember the options. Yeah, vertically stretched by a factor of, vertically shrunk by a factor of, or no vertical stretch or shrink. So this is half. So what do you do? What happens when you multiply by half? Does numbers get bigger or smaller, or stay the same when I multiply by half? And hopefully you say numbers get smaller. So since numbers get smaller, I'm going to use the words vertically shrunk and then by a factor of half. Okay? And keep in mind, yeah, your A value is -½ Do you see a negative sign next to this half? No, I only see the number 1/2. Don't put -½ If you put -½ I have to mark you wrong. Okay, it's vertically shrunk by a factor of half. It's not vertically shrunk by a factor of -½ we cannot write that. All right? So third line, horizontal shift left 5 units, horizontal shift right 5 units. So this negative sign is going to pick left or right. So I hope you say left. Okay. Vertical shift up 16 units, vertical shift down 16 units. So this negative sign, hopefully you pick down. Okay. So vertex, that's your H and K, right? -5, -16. This guy reflected, right? Not shifted, this guy reflected. I was going to say shifted, but this guy reflected. So it's not a U-shaped graph anymore because he reflected. He's upside down U. So since he's an upside down U, the vertex is at the very, very top. So we're going to call that maximum value. Okay, and your K value is -16. So yeah, we have the highest point on the entire graph being -16. Okay, domain, that hasn't changed in every single problem. It's still X, all real numbers. Okay, range pretty much is the exact same thing also, right? You still got the g of x colon g of x. You got your K value written right here. The only difference is sometimes we put less than or equal to, sometimes we put greater than or equal to. So this time we put less than or equal to. And the reason why we did that is because A is negative. So when I translate this statement, it's the graph is lower than the height of -16. Yeah, the graph is lower than a height of -16. So let's look at this picture. My blue line, which is known as the graph, is lower than the height of the vertex, which is at negative 16. Okay, so you can use this picture to help translate the wording so that you can get the range. Okay, so I think that's the last problem. The next one is going to be homework. Yep, it is. So I wish you the best of luck on this lesson. Sorry it was a long lesson, but yeah, these types of lessons that span the whole course of the year, where you're going to see it happen every single time when we get through it the whole year, they're going to take a long time because it's super important. Okay, so just try your best, and yeah, I'll see you in class. Bye bye.